Okay, this is the second video on ellipses, and I'm just going to work through one or two examples so you guys can see the algebra and see how it works. As far as it goes, last video we said the standard form, or the way we write our ellipses, is generally x squared over a squared plus y squared over b squared equals 1. It tells me my a, my b, from that I can get my c, I can tell the center, and I can graph the whole thing, and that's good. But the actual general form of an ellipse looks more like that. And ultimately, when we understand all of the conics and work through all of them, we're just going to have a bunch of general equations that look like this. And then it will be up to you guys to algebraically determine what type of conic section it is. Which means you need to know how to do the algebra to do it. And ultimately, well, if I want to find what conic it is and work with it, this one's obviously going to be an ellipse. But if I want to do that, isolate the x's and the y's and bring the constant to the other side, because we want to make it look like that standard equation. So if I kind of rearrange, I get 3x squared plus 12x plus 5y squared minus 60y equals negative 177. Now, in order to do this, we're going to have to do that old algebraic trick that I'm sure you all love, complete the square. So just as a quick review, to complete the square, the leading coefficient of the quadratic terms has to be 1. So factor out the 3 here, and I get x squared plus 4x plus factor out the 5 here, y squared minus 12y equals negative 177. Now complete the square. So here, x squared plus 4x, half of 4 is 2, square that you get 4, so you add 4. All of you know, whatever you add to the left, you have to add to the right. Just keep in mind, if you remember completing the square, I didn't actually add 4 here, I added 12, because there's a 3 out in front. So I add 12 over here. Do the same with the y's. Plus 5, y squared minus 12y, half of 12 is 6, square 6, you get 36. Add 36. I didn't actually add 36, I added 36 times 5, which is 180. So I add 180 over here. Now if I did this right, that should be a perfect square. It'll factor as x plus 2 squared. Plus, that should be a perfect square. That's y minus 6 squared. And it's equal to 180 plus 12 is 192. 192 minus 77 is 15. And now the problem is, well, it kind of looks like an ellipse, or the equation of an ellipse, but not perfect. The equation of an ellipse is always equal to 1. So now with this step, make that equal to 1. Divide everything by 15. When you do that, you get 3 over 15, which is 5 on the bottom, x plus 2 squared on top, plus the y minus 6 squared stays on top. 5 over 15 is 3, equals 15 divided by 15, which is 1. Now that equation looks like it should. Now, we're not going to graph this, but as far as it goes, I have a 5 here and a 3 here. This is bigger, which means it's oriented in the x direction, horizontally. Where's my center? Well, in this case, I translated it, but plus 2 minus 6, you know, you just flip the signs. The center is at negative 2, positive 6. Then I just need to find my A, my B, and my C. A, let's see. Keep in mind on your equation, that is not A, that's A squared. This is B squared, which means if A squared is 5, A is root 5. If B squared is 3, B is root 3. Now we need to find C. We have the Pythagorean relationship, B squared equals A squared minus C squared. So let's see, 3 equals 5 minus C squared. Add the c squared, subtract the 3, you get c squared equals 5 minus 3, 2. C squared is 2, which means c equals root 2. And now there's your ellipse right there. There's all the information. If you wanted to, you could plot this. You have your center. You know it's horizontally oriented. You could go a distance root 5 to the left and the right, a distance root 3 up and down, and then a distance root 2 to the left and the right, and label everything, but those are really messed up numbers, so I'm not actually going to graph them out. But ultimately, this is the goal. I give you some information last time we did it where I gave you, say, the center and the foci. Here I give you an equation in general standard form. You do the algebra, you use your understanding of an ellipse in order to graph it and find all the key points, major arc, minor arc, stuff like that. I'm going to stop right there because that should be more than enough information to help you with your homework. And I will make more videos for the next conic section either later today or tomorrow morning.